Alright, so in this video I'm gonna be talking about on a very important dataset for event extraction, which is called BioNLP'09, and it's a shared task BioNLP'29. So I'm gonna be focusing on this paper in 29. So the paper presents the design and implementation of BioNLP shared task and reports the final result with analysis. The shared task consists of 3 subtasks, each of which addresses biomolecular event extraction at a different level of specificity. The data was developed is based on that GENIA dataset corpus that we always use. The shared task was run over 12 weeks, drawing initial interest from 42 teams. Similar to LLL and BioCreative, these are good important datasets. Similarly, BioNLP'09 also addresses bioinformation extraction, but takes a definitive step further toward finer-grained information extraction. While LLL and BioCreative focus on a rather simple representation of relations of biomolecules, like protein-protein interaction, but BioNLP concerns with the detailed behavior of biomolecules, characterizes biomolecular events. We call them bioevents. The difference in focus is motivated in part by different applications envisioned as being supported by the IE methods. For example, BioCreative aims to support curation of, for example, protein-protein interaction database such as MINT. For a long time, one of the primary tasks of bioinformatics. The BioNLP task aims to support the development of more detailed and structured databases. For example, pathway analysis, if you want to work with Go, which is called gene ontology annotation, which are gaining increasing interest in bioinformatic research. So this is an example of event annotation. The failure of this P65, and you see that the protein annotation T3 is given as a starting point. The extraction of annotation in bold is required for task 1, and this 2 log for task 2 and M1 for task 3. So this table shows the event type addressed in the BioNLP. The event types were selected from GENIA ontology with consideration given to their importance and the number of annotated instances in the GENIA corpus. The selected event types all concern protein biology, implying that they take protein as their theme. As you see, all of them take protein as their theme, except these 3 types, which not only take protein but also take events. So it's either theme or cause of that, but it takes argument as protein as argument, or sometimes event as argument. And we have target event types. So the type of the filter entity is specified in parentheses. The filler entity of the secondary arguments are all of entity type. which presents any entity but proteins. For example, T stands for theme, C stands for cause, P is protein, and this is event. So we have, for example, around 7,000 sentences for training. So the BioNLP task targets semantically rich event extraction involving the extraction of several different classes of information to facilitate evaluation on different aspects of the overall task. The task is divided into 3 subtasks addressing event extraction at different levels of specificity. For example, task 1, which is core event detection of type, text-bound events, and assignment of given proteins as their primary arguments. The second task is event enrichment, so it's recognition of secondary argument. And the task 3 is negation and speculation detection of negations and speculation statements concerning extracted events. The name entity annotation of Genia corpus has been somewhat controversial due to differences in annotation principles compared to other biomedical name entity corpora. For instance, the name entity annotation in the widely applied gene tag corpus does not differentiate proteins from genes, while Genia annotation does. Such differences have caused significant inconsistency in methods and resources following different annotation schemes. To remove or reduce the inconsistency, gene tag style name entity annotation, which we term gene or gene product, this is gene or gene product annotation, has been added to the Genia corpus, which with appropriate revision of the original annotation. So the Genia event annotation was made based on Genia event ontology, which uses a loose typing system for the argument of each event class. For example, it is expressed that the binding event involves 2 proteins. And in the case of CD40, its domain takes part in the binding. Without constraints on type of theme arguments, the following 2 annotations are being legitimate. Thus, we fix the types of all non-event primary arguments to be proteins. For Genia event annotation involving themes other than proteins, additional argument types were introduced. For example, site 2, theme 2, theme 1, theme 2. But site, so the CD40, this protein and its domain are associated by argument numbering. To resolve issue related to the mapping between proteins and related entities, systematically we introduce partial static relation annotation for relations such as part whole, drawing in part and similar annotation of the BioNLP corpus. So this is an entity annotation to example sentences. Alternative names for same object are frequently introduced in biomedical texts, typically through a position. So you see in this figure that 2 expressions, B cell transcription factor and BSAP, are in a position and refer to the same protein. Consequently, in this case, the following 2 annotations present the same event. So meeting with the community-wide participation, The BioNLP shared task was successfully introducing fine-grained event extraction to the domain. The evaluation results of the final submissions from the participants are both promising and encouraging for the future of this approach to IE. It has been revealed that the state-of-the-art performance in event extraction is approaching a practically applicable level for simple events, and also that there are many remaining challenges in the extraction of complex events, such as, for example, nested events or repeated events. A brief analysis suggests that submitted data together with the system descriptions are rich resources for finding directions for improvement. Finally, the experience of the shared task participants provides an invaluable basis for cooperation in facing further challenges.